Okay, so I've got the Zenith on the bench to replace this transformer, the one that was causing the video to act up. I confirmed that by disconnecting the convergence leads, and there was all kinds of weirdness going on there. You disconnect that, it clears up. It's got weird voltages on it. It didn't make any sense. I think what I was doing is having a breakdown of the insulation between the convergence winding and the primary that would manifest when you have a really high peak, like you get with an inductive kickback in a sweep circuit. I never could find the actual problem using my conventional meters, but again, you're dealing with, much higher voltages. I don't know what the inductive kickback voltage is, but I'm sure it's in the hundreds, if not 1,000 volt range when that thing kicks back. So I think that's the problem. You just, I can't really find it with my typical voltmeters. Although I'm sure it's the problem because disconnecting the convergence leads cleared the problem, but you had lousy dynamic convergence. And I, just to make sure it wasn't the convergence board itself, the actual controls and the plug over there, I plugged in a spare convergence board, and it still had vertical wackiness. So I'm sure this is the problem. We'll come to him in a minute, but in the meantime, I was working on this peaking control, and it's not functioning right. This is me adjusting it. I mean, that's like zero movement. It's on R times 10,000. Just touching it makes it jump all over the place, and it goes to nothing, and it's infinite within just, I'm talking about that you can just almost just a pressure. This is me holding it solidly against one end, and this is me moving it like 1 degree, and it opens up. I was hoping that maybe I could use the other side here, but as you can see, actually, I have okay, let's see if I can do it with the other side. Now I'm going to go over to see if I can use the other side of this. Well, it's going to fight me now. To use the other side, I need to go here, and let's see what happens when I hook up to this side. Okay, open. It's the same thing. On the other one, if I just touch it off of the full extension, off the full closed position of the pot, boom, it's wide open again. So both sides of this pot are shot. My presumption is that there's something happened to that element that caused it to crack. I can't imagine why both sides would be cracked, especially since this isn't even connected to anything. But it sure is. So that's a problem. And what's particularly problematic about it is this thing uses one of these cool Zenith type actuators. So what I'm probably going to end up doing is taking this pot off, which is fairly easy, removing the section here, that actually is the element. Typically what happens is the wiper part of this is okay. The element can become cracked. So my idea is I'll take this out, be very careful to salvage this pot, remove this Bakelite element here, and then replace it with a donor pot, keeping the form and the fit of this consistent with the Zenith, because I don't know if I have any of these pots or how they'll work with this push through business. So I pretty much have to salvage that. As a minimum, I have to salvage the center wiper, which means taking a pot apart. So that's just the way it is. I'm going to have to do that. But we'll take care of that. And the peaking control was noticeably bad because the peaking has like an on-off switch. It didn't have any kind of a variable function when it was working before. I just had it either fully peaked or fully attenuated on the peak. So with no real adjustment whatsoever. So I knew there was a problem, so I don't mind doing this one. I got it open. So we'll take care of that. We'll take care of that transformer. I just got to go to my jobber and order this thing up, and I'll put that new transformer in there, and then we'll be good to go. But that's it for now. More later on the Zenith 20X1C36 cabinet. There you go. All right, more later.